Okay, so today is, I don't know what day it is. 10th of April, 2024. We're doing the last stuff in Math 98, solving equations by elimination. What we did already, this is what we did already. We solved a system of equations like this. How? Graph the first equation. And the line, you'd have some line that you graphed. Graph the second equation. You got some other line. And where's the solution? Where they meet, right here. This x value, that's the x number of the answer. And this right over wherever it comes over here to the y value, that's the y value. The coordinates of that point, that's the answer. Okay? The second way that we did last time, okay, was we took one of these equations, solved it for one of the variables, and I was looking for one with a coefficient of 1 or -1, right? Why? Because you wouldn't create fractions when you solved it for the variable. So my eyes are immediately drawn right here. It'd be easy for me to take this and move it over here, make it -3y, right? Over here. So now that ain't there no more. And now I know that in the other equation, x, I can replace x with that. So I would have 2 times, in parentheses, 11 minus 3y minus the 5y equals -4. You see how that worked? You take one of the equations, solve it for a variable, like x equals this, or y equals this, and then put that thing that it equals into the other equation for that variable. And then you have only one, when I did that, I would only have one variable. So this would become 2 times 11 minus 3y minus 5y equals -4. Like that, okay? All that I did was I took this right here and I put it in place of that x. Okay, girl, you see that? Looked like it was a little iffy on it. Because this was x to x. So now I could solve this. I'd get 22 minus 6y minus 5y equals -4. I could put those two together, get -11y. I'd still have a 22 and equals -4 like that, right? I could do that. I could then move this 22 over here and then divide by -11. I get the y, and I could get the y value. So y equals some number. Once I have that, I take that some number and put it up there into that equation where I solved it for x. And I get 11 minus 3 times whatever y came out to. That'll be what x equals. Okay. So here's way number 1. You graph them. This is kind of way number 2. It's called substitution. Then here's way number 3. It's going to describe this. If I took this equation and multiplied it by -2, okay, then this would be -2x minus 6y and -22, right? See, when I just multiplied all the numbers by -2.
Yeah.
Okay, you see what I did? And now I'm doing that. Didn't just pick out a random number. I did that on purpose so that when I add these two equations up, what happens to the x's? They cancel out. And I would get like -11y equals what, like -26? You see that?
Yeah, yeah.
No.
How'd you get 11Y, negative 11Y, where's next one? Oh, yeah, okay, I got you, yeah. All right.
Yeah, see, the X's here canceled out.
Uh-huh.
The Y's added up, and the -4 and the -22 made the
Yeah, I got
-26.
you, I got you, yeah.
But the goal was I eliminated the X's. So if I was to multiply the first equation by -2 and add the two equations together, would the Y's get eliminated?
Would they?
This is true or false. They're asking you that. If I multiplied the second equation times -2 and then added these two equations up, these two guys here, after I multiplied the bottom, would the Y's get eliminated?
No, they didn't, they were still there,
What did get eliminated?
the X's.
The X's would get eliminated. This would be false. If this had said the X's are eliminated, the answer would be
True, true. Yeah.
true. So let's pretend I didn't want to eliminate the X's.
Did want to?
Huh?
You said you did want to?
Now, what if I did want to eliminate the Y's? How could I accomplish that? Well, what if I multiplied this one by 3? So that became -15. And I multiplied this equation times 5. So that became +15.
Okay.
Would the Y's get eliminated then?
Yeah.
Yeah, we're gonna try this. So that would be 6x minus 15y equals -12, right? You see that? You see that, where those numbers came from?
You just multiplied everything by 3.
Fact.
Yeah.
And then, so if I multiplied the bottom one by 5, what would it come in, what would happen?
5, X plus 15Y equals, 55.
And now if I add these up, sure enough, the Y's are gonna cancel. And I'll get like 11x equals whatever that is,
67.
43.
Yeah.
And then x would be 43 over 11. That's what x would turn out to be.
Okay.
Okay? But see how we accomplished that? You see how we accomplished that? Do you really? Okay, good.
What was the one that we did Monday?
Substitution.
That was substitution.
So if I was going to solve this by substitution, which variable would I solve for? In the which equation, top or bottom? The bottom equation. Yes, and why did you pick that?
Because
Its coefficient is 1. Okay. But if I took the second equation here, it says multiply the second equation by -3 and add them together, would the x's get eliminated?
Yes, they did.
You think they would? What do you think? Why do you think that? You're not giving me a lot of confidence here. Why do you think that the x's would get eliminated?
so if you added the 30x and the -30, it'd be 0.
Oh, now you're giving me. Okay, good. Yeah. And if I did, I mean, typically, this is just what the way I do this twice as long as y'all. I would go through here and I'm gonna write down, I'm gonna multiply this one by 1, I'm gonna multiply this one by -3. and I would get 3x minus 4y equals -2. I just write it over again. Then I write the second one, -3x minus 15y equals -39. Okay. And then when I add them up, these guys go away. I wind up with -19y equals -41. Right?
Yeah.
So then y would be 41 over 19. A little bit more than 2, right? Because 2 times 19 would be 38. So if I was solving this by graphing, you think I would actually see that lines were crossing at a y value of 41 over 19? No,
Graph is huge.
no. I would see they're crossing a little bit more than 2.
Okay,
That's what I would see.
okay, because you just divide 19 into
Just make it a mixed
41.
number.
Yeah, oh, no. I would, in a graph, I would never get 41 over 19. I would have to go to an algebraic method like this. Okay, and one other thing that came up on Monday was when I do that substitution, things could happen, right? What could happen would be like you get like x equals 3. That means the lines crossed at x equals 3. Right?
Yep.
What else could happen?
0.
0 equals.
I get something like 0 equals 3. What does that mean?
Mm,
The lines are parallel. They don't cross. There's no solution. And what's the third thing that could happen?
Two numbers that are the same.
Yeah, I get like 7 equals 7. Well, that means it's really the same line and there's an infinite number of solutions. This business here, same thing applies when we're doing this by elimination. If you do this and you come down here and instead of getting y equals this number, I got 0 equals 3, no solution. Or if I got 7 equals 7, or in this method, it's typically 0 equals 0, the way they're laid out, then that would mean it's the same. Okay, there's an infinite number. You following that? Okay, good. Yeah. Now, I got this 41 over 19. That's what y equals. How do I get the x number?
You would use 41 over 19 in the top equation. It would be, you would make x that.
That's exactly what we teach. That is not what I would do.
Okay.
Okay. Why would I not do that?
This is a fraction.
Because it's ridiculously difficult.
Yeah.
Okay. Yeah. I would do this. This is what Joe Fairclough. Okay. If I got a number like that, there is no way I'm going to stick 41 over 19 into either one of those. Okay, because that's what y equals. I would come through this thing and go like, okay, I know that y equals 41 over 19. I would go through this thing and redo it again, but eliminate the y's. How could I eliminate the y's? I'm looking for what could I multiply the top and the bottom equations by so that the 4 and the 5 here become the same number with opposite signs? Go.
You do the top by, 5 and you do the bottom by 4.
You see that? And then it would be -20 and +20, right? So sure, I would multiply this one times 5, this one times 4. I would get things here. I would add them up. the y's would cancel out and I would get, something x equals some other number, so that I would divide by this something, something here, and x equals that. And then there would, and I'm here to tell you, it's almost a guarantee it's gonna be over 19. Okay, it'll be some kooky weird fraction, but it'll probably have 19s in the bottom.
And you solved for X and solved for Y.
Then I've eliminated the x one time and I eliminated the y one.
And it would it have been the same if you would have put 41/19 as for Y?
Yes, you get the same numbers, but it'll be simpler because the only fraction that in this right here, this method of going down like that, the only thing that I have to do with the fraction is like put a circle around it. And I'm loving that, okay? I'm not loving taking 3x minus 4 times 41/19 equals -2 and then solve that for x. I ain't loving it. Now, if this initial y had come out to like y equals 2, then what would I do? I'd probably stick it into the bottom equation. It's probably what I'd do. And I'd get x equals 13 minus 10. That I would do. I wouldn't go through the trouble of resolving this if I got some simple number like that. Good. Okay, well, should like this. True, false. Yeah, I got that. Yeah, so they did get eliminated. Okay.
And you really don't have to worry about the other stuff, you're just,
What?
like,
solving.
you're just saying true or false to the cancel.
As far as this goes, in
As far as this,
actual practice,
you need to
you need to actually do
solve for
it
X
and
Y.
then get x and y. But this is just to give you the idea of what's going on. Okay. So, and maybe we'll do this one all the way through. Will that, is what they say true or false? True, false?
I'm gonna say,
Really?
yeah,
I got 2 votes. What's your vote? Oh, she's going with true. So why do you had true and then changed it to false? Why did you do that?
Because I looked at the signs, it's gonna make the bottom negative and then negative and negative is gonna just add.
that's what I was thinking.
Tricky, huh?
Yeah, that's what
So this is false. So what should this box say? Multiply the first one by 4 and the second one by
it's three.
+3. So let's do it. If I do this one times 4, this one times 3, then I'd get 20x minus 12y equals -32. Is that right? Then this one would be 3x plus 12y equals 51. Trust me. So what do I get? 50, no, 23. 23x equals, and then what does that come out to? 51 take away 32? Is that like 19?
Mhm.
Okay, I think it's coming out to 19. So X would equal,
19 over 23.
yeah, 19 over 23. I could take that and put it up there for X. And I would probably, if I did, I would choose that X so that I didn't have to multiply it by 5 or something. But I'd probably not do that, right? What would Fairclough probably do? Go through this and eliminate the X's, right? So what would I just need to take the bottom one, multiply by -5, right? So if I did that, if we did that in like green. So if I took the top equation times 1, the bottom equation times -5, I would get 5x minus 3y equals -8, and I would get -5x minus minus 20 equals 17 times, it'd be like -85. Okay. The x's cancel. I get -23y equals -90. No, that's not a 5. -93. Divide by -23. Then I just call that 93 over 23. But notice how these both have the same denominator. That's going to be super common.
If they don't have the same denominator, is that a bad thing?
Nah, it would probably just mean that one of the fractions simplified. You know, you could reduce the fractions. But with these all being whole numbers, no fractions, they're gonna wind up needing to have a common denominator for it. No. And on the test, I think I just have stuff like this and I just say, solve it by whatever method you want.
So it won't be asking if it's true or false on the test. No, you saw it. We could do that. That would not.
Good, but we ain't gonna. Well, no. Somehow I gotta get to, oh. And let me see, what's the last thing here? Is it thinking or something? Yeah. Oh, no, it's not gonna let me move that, is it? So, this is just word problems. But this is why we don't, math is fun in and of itself, but we really have to solve some real life problems. That's why we take these classes. So we don't actually want to solve this. We just want to know which of these answers meets these requirements. The length of a rectangle is 2 feet longer than the width, and the perimeter is 24 feet. The perimeter of what?
A rectangle.
A rectangle. How do you get the perimeter of a rectangle? You get the perimeter of any old thing.
With times.
Just add up all the sides.
Yeah, okay.
How many numbers are you gonna add up? 4, okay? So if I just look one, is the length 2 feet longer than the width?
No, it's
Oh, yeah, yeah.
No, it ain't.
So B is,
It's twice as long.
Twice as long.
It ain't 2 feet longer. Is this one 2 feet longer? Okay, is this one 2 feet longer?
7.
Five.
Yeah, yeah.
Okay, so both of these meet this first requirement that the length is 2 feet longer than the width. But the perimeter needs to come out to 24. What would it's not that one. You think B? Why do you think B? Well, what would the perimeter of this one be?
6 plus 6 plus 4 plus 4.
Yeah, does that come out to 24?
No.
Or does it come out to? Comes out to 20. Okay, what about this one? Is it?
Yeah.
So there it is. You see that?
That wasn't that,
Say it again?
that wasn't that bad
No. Well, you didn't actually have to
to do
put
it.
down the algebra.
Yeah.
Okay. Do this one the same way. 2 computer disks and 3 notebooks cost $27. However, 5 computer disks and 4 notebooks cost $57. Oh, brother. 2 computer disks and 3 notebooks. So 2 of these and 3 of these, is that going to be $27? 2 of these would be 6. 3 of these would be
Yeah.
27. So that would be, this would be 27 just for the notebooks.
Yeah.
So you wouldn't, that ain't gonna work, right? How about 2 of these and 3 of these? That'd be 18 and 9, that'd be 27. Okay. Does 5 of these and 4 of those cost 57? 5 of those,
Yeah.
yeah, that works. Okay, so if I was gonna actually solve this though, here's what I would have to do. Okay, this is like just giving you the answer and saying, does this meet the requirements? So here's what I would do here. If I wanted to write this out, I'll say, we want to pick out a variable to represent whatever a computer disk cost.
D.
Hmm?
Would you just use D?
D, well, I could use D. D for disk.
Yeah.
So, and D is gonna be however much a computer disk costs. And what would could I use for notebooks?
In.
N. Okay, now this is what we do in real life. We don't always use X and always use Y. We use D for disk, N for notebook. So when we get to the end, we know we get D equals this. We don't have to figure out, is that a notebook or a disk?
Would you do 2D and 3N?
Yep, I go 2D plus 3N has to equal how much? 27. And then how am I going to write that?
B
5.
or N.
And then there's my 2 equations that I have to solve. How could I solve those? I could graph them. I could kind of imagine the D is the X and N is the Y. And I could just graph those 2 equations. And I would get something that looks like, and then that would be like disks and this is notebooks. And there would be the answer. How else could I do it? I could solve one of these equations for one of the variables,
Substitute it for me.
but it doesn't look like I'm going to be able to get away with no fractions, right? So I would probably go back to the one that we just did. And I would say, okay, well, and that's not exactly what they're asking you to do here, but this is what you are going to wind up doing in real life. 2D plus 3N equals 27. 5D plus 4N equals 57. And I'm going to go like, well, if I tried to eliminate the D's, I could multiply this one times -5 and this one times 2 and make that -10 a +10, right? And then I could go through and I'd have, it's an equation here, an equation here. These D's are going to cancel, but I'd wind up with N equals some number. Then I would know how much a notebook costs.
Then you can do the same thing.
And then I could, well, this is going to be probably a whole number. Okay. So it's going to be, looks like this was one that worked, right? It's going to be that one. It's going to come out to 3. And then I could just say, well, okay, I could just use this one. So a notebook, I could just put 3 in there and solve 3. Good. I don't have to go through and do it and eliminate the N's and get the D, because this come out to just an easy 3, no fraction.
Is that what will be on the test, and we'll have to do that?
I'm not sure. Probably some of this too. One of these. So, system of equation in X and Y where you have a smaller number and a larger number that add up to 15. It says let X be the larger number and Y be the smaller number. So they add up to 15. Then how could I, if my two numbers are X and Y, X is the bigger number. So how would I get that they add up to 15?
X would have to be, I guess, any numbers you want.
What would the equation be?
The X plus Y equals 15.
X plus, if they add up to 15, and it would just be X plus Y equals 15, something like that.
Y equals 15?
Well, no, it just says they have to add up to 15, not twice the first and twice the second one, or nothing like that. And then have a difference of 1. What does difference mean? Subtract. And I would subtract the bigger one, take away the littler one. What would that look like in an equation? X is the bigger one. X minus Y has to equal 1. Okay, so that looks like, there's my answer, that one right there, right? And then if I think that's all that it's asking you to do in this thing here. But could you solve it? Could you solve this system? See this symbol right here? That usually means a system of equations that we want to solve. It looks like it's set up to just add right now, doesn't it? If I just added them up, what would I get? The y's would get eliminated, wouldn't they? I would get 2x equals what? 16. You see that?
Okay, yeah.
So, I mean, if I just add these two together, I get 2x equals 16. So x equals what? 8. And then what would y need to be? Show me what y would need to be. Yeah.
Not a clue.
Well,
I'm lost.
they have to add up to 15.
Okay, all right. So if X is 8, just add a number that would equal 15?
Yeah.
9, 10, 11, 12, 15, so 7.
And then check the other one. Do they subtract to give you 1?
Yeah.
Yeah. Yeah. And then y equals 7. Generally speaking here, okay, if you get the problem like this, the question would be like, what are the numbers? All sentences. The answer won't come back x equals 7, y, or x equals 8, y equals 7. That ain't how it's going to work. you're gonna say the two number, you're gonna write it out. The two numbers are 8 and 7. The answer comes back in the same form that the question is posed. Okay? If the question came to you like that, then the answer comes back in that same form. X equals 8, Y equals 7. The response comes back in the same form that the question is given to you.
Do we need to put the two numbers are
Yes.
8 and 7?
Yes.
X being 8, Y being 7?
No, you don't even put that last business. You wouldn't have to put that. You could put, you know, the larger number is 8, the smaller number is 7. You could put something like that. See how this, there, here's the question and here's the answer. The answer is coming back in the same form that the question is being posed. Two numbers, total 54. So what can we use for the two numbers? X and Y. Yeah. If they total 54, then what does that mean? Add to give me 54 and a difference of 16. How do I write that? And now it looks like, again, they're kind of set up to eliminate the y's, aren't they? So if I just add this up, I get 2x equals 70. So x equals 35, is that what you're saying? Yeah, okay. And then y would equal,
You get X is 35 because you divide 2 into, okay, yeah, I got you.
Yes.
Oh, yeah.
so then, you know, I could take this 35. No, put it over here for x. 35 plus how much more makes 54?
The 89?
Say again?
89?
89? No, x, I meant 35 plus how much more makes 54? You know, or you could put it right there. 35 take away what makes 16?
I thought you were saying what Y was.
Yeah, what is what?
Is it not 89?
No.
Because oh, it'd be subtracting because I.
Yeah. How much? 19. Okay, so the larger number is 35, the smaller number is 19. And you could check, and you should. Do they add up to 54 and do they subtract to 16? A first number, okay, we'll say X is the first number. Second number, we'll call that one Y. So a first number plus, how do I do twice the second number? 2Y equals 1. Twice the first number, how's that going to look?
2X.
Plus the second totals up to 26. I could graph these. They're in X and Y. Doing exactly what you were doing earlier.
Yeah.
I could solve the first one for X. See that? By just moving the 2Y over. And then if I did that, you know, that would be like X equals 1 minus 2Y. And then take that, put it in the other equation. Do substitution. And you'd get like 2 times 1 minus 2Y plus Y equals 26. So that would become 2 minus 4Y plus Y equals 26. And you could come out here and get Y equals whatever it equals. Okay, it looks like y equals maybe -6. That looks like, no, not -6. This would be -3y and 24, yeah, -8 then. So we're saying y equals -8, and then how do I get x?
Fine.
1 minus 2 times y. So 1 minus 2 times -8. That'd be like 1 plus 16. So it looks like x is 17, it looks like. And then, so it looks like the first number is 17 and the second number is -8. Now, if I do the first number plus twice the second number, do I get 1? Do you? You get -1? Like 17 plus 2 times -8, 17 plus -16, yeah, that's 1. If I do 2 times the first number, 17 times 2, 34, plus -8, does that come out to 26? Yeah, it does. So which one would be the smaller of the two numbers?
-8.
The -8, it's the less than one. Okay, so the first number is -8 and the second, or the smaller number is -8 and the little probably said, the bigger number is 17. But instead of going this yellow route, what else could I have done? I could have solved it the way we did at the start of class today by elimination and said, okay, well, if I took this equation times -2, this equation times 1, then the x's are going to get eliminated, right? So I would get -2x minus 4y equals -2, and 2x plus y equals 26. They eliminate, -3y equals 24, y equals -8. You get the same, of course, you get the same.
That seems like an easier
That's
way.
sure was way easier.
This is going to a lot of times be your default method.
Yeah.
And if you kind of solve it, I think it's called like the hockey stick method. Okay. By going like coming across and then down like that to get your first number. Well, then there's going to be this space right here to take and like substitute that y in here, and you get like x plus 2 times -8 equals 1. So then that'll be like x plus -16 equals 1. Add 16, and x equals 17. So there'll be a space right there for you to kind of work it out. And you wind up with the two answers at the bottom. It's just,
Is there ever a reason why we can't do it like this? We have to do it the other way?
When would we have to do it like this? Doing it like this, when would we be like, we can't do it like this, we gotta do it like that?
that answer's no. There's never a way. There's never. a way.
Okay, so you can always do it like this.
So it's just
Yeah.
whatever.
And here's
Easier.
where, when you would not do the pink part of this, if this came out to -8 over 37,
Then you would just.
I would not do this pink part. I would do another one over here and eliminate the other variable. So that, and my answer would still be at the bottom, and it'll be some cookie fraction.
So if you end up with like, you do the first part, and you end up with like a weird fraction at the bottom, you probably want to go on and do it again.
Yes,
Yeah.
it just eliminate the other variable this time.
It would be easier to do it that way than it would be this way.
Yeah,
Mhm.
my opinion.
It looks easier.
And if you're gonna program it into a computer, this is what you do. You're probably not gonna do the other stuff. Okay, you're gonna program it in like this. I've done it several times. Okay, so you read this and what are the things that you're trying to figure out? What are you having to figure out? Oh, well, child's ticket, and what's the other answer gonna be? Adult ticket. So what variables are you probably gonna use?
A and C.
A and C. That's probably what I would use too. Okay? So, 3 adults and 4 children costs no, right? 2 adults and 3 children equals and so on. What method are you going to probably use? What we just did. I'd probably like multiply the top equation by 2 and the bottom one by -3. Okay. Are you going to, let's say you solve this. Let's just say you solve this, you come across here, you come down and you get like C equals -2. Yeah, how come you're looking like that? What's wrong with that?
How can it be -$2?
That's why. Okay, if you got that answer, what would you know?
That's wrong.
What's wrong?
You did something wrong.
Yeah.
That's what, they're not gonna pay kids to ride the train. Okay, you need to recognize that it's not that, okay?
And one more time, can you do the substitution one? You don't have to do it, just how, because
Well, let me see if there's gonna one come up here that will be a good candidate for substitution.
it's just a lot of reading.
Huh?
He said, oh man, I said, it's just a lot of reading.
Hey, I know. So what are the, there's like a daily fee and a mileage fee. Right? So what are you probably gonna use for the variables?
DNN.
DNN. So, here's my daily fee, my mileage fee, or charge, okay? So, let me see. First trip lasted 4 days and drove 450 miles. So, 4 days plus 450 miles equals 227.50. What's the second one gonna be? What's the second equation gonna be? Here it is.
3D plus 200N equals 150.
There's my 2 equations. And, this is money, so it's 2 decimal places. Typical for money, right? 2 decimal places. I could get rid of the decimal places by just taking the first one and multiplying times 2, right? Make it 40 plus 900M would equal 227.5 times 2. And that would have no decimals in it. Okay. And now if I was gonna solve this by, what was it, it's substitution that you said? Would either of these look like they would be good candidates for substitution? No, no. But let's just say it was that. It was only 1 day and 450 miles. Okay, and it cost you that much money. Then what would you do? I would probably take that one, solve it for D. And you'd get D equals 227.50 minus 450 M. This is substitution method, okay? then you would take that and put it where?
15.
In the other equation for D. It won't be pretty, okay? It ain't gonna be easy. That's why we go to that other one. The elimination is the
Just give that in
default.
my mind.
If the equations are really simple with really low numbers and one of them has a coefficient of 1, substitution. Okay, so this is the same stuff here. The perimeter. So, and this is the same. This looks like it might be a little bit different. In that figure, M and N are parallel lines. So you see the two horizontal are parallel lines cut by this transversal T. Okay? The value of X is 10 degrees less than the value of Y. And where can you see that in the picture here? This and this are called, those two angles are called alternate interior angles. They're the same amount. Okay, so I know that X equals Y minus 10. Those are equal. And it says that, okay. The value of X is 10 degrees less than the value of Y. But this right here, what does that tell me? X plus Y equals a straight line. How many degrees are in a straight line? 180. Okay, you kind of need to know that. Okay, a straight line has 180 degrees. Yeah.
Write it down.
Well, I'm not saying that on the test. It's just a thing that you need to know. Like, if I turn around, I do a 180.
Yeah.
That's like that, right?
Yeah.
I go through 180 degrees. I turn all the way around. If I do a 360, then I'm already did it, so I'm not gonna do it. But I would be turning all the way around. So if I just turned, I'm going this way and I turn around, that's 180 degrees. Okay, if I go all the way around, that's a 360. All the way around the circle, 360. Halfway around the circle, 180. So what do I know here from this right here in the picture? X plus Y equals 180.
Half circle.
Half circle. This looks like it's a good candidate for substitution, doesn't it?
Mhm.
It's one of the top equations already solved for X. So what would I do here?
You would put that in.
Yeah, I take this and put it down here. And what would I write? You tell me what I'm gonna write.
Your X and then.
You're not gonna write X
Put minus 10
Yeah.
plus Y,
equals what?
180.
You agree with that? Yes. Yeah, me too. Okay, yeah. This was just X. Okay, so looks like, could I put the Y's together? Move the 10 over. Equals what? 190. So then Y would equal, looks like 95.
You're the last picture.
Okay, you agree?
Mhm.
If you got $190 and
Yeah,
each of you get half,
Because half of 90 is 45, half of 100 is 50.
good. Okay, that's what went through my head too. Okay. This would be 95. Okay, so there's what Y is. How do I get X?
You would put 95 in for.
That green circle.
Minus 10. It would be 85.
It'd be 85. If you're putting the 95 right here. And 95 minus 10, 85. No?
Yeah.
Okay, now I think that's all the questions, but here's some other stuff that comes up in real life. Okay, let's say you had two consecutive numbers. What is consecutive numbers? Yeah. So how could I represent two consecutive numbers?
X and then X plus one.
There you go, X, and the next one's X plus one. What if I said two consecutive even numbers?
X and then X plus two.
See that? What if there were two consecutive odd numbers?
X plus three.
It's tempting.
No,
If the first one was 5, what's the next odd number?
So,
7.
it'd be two.
It's 2 more, right?
Mhm. But
So-
if the first one was 4, and then the next one would be even.
If you added 2. So 2 consecutive even numbers, X plus 2. 2 consecutive odd numbers, X plus 2. It works either way. And how that comes up in real life, like house numbers, apartment numbers and stuff like that are all often like when you go down the hospital, they'll like be odd, and even as you go down the road. Or as you go through an apartment building or something, there'll be all the odds will be on this side, the evens will be on that side. And there may be something about that.
Hotel rooms. Do the same thing.
Yeah. And it may not be, it may be in the hotel, it'll be like 1, 2, 3, 4. Here in the United States, we do a lot of, all the odd numbers are down one side of the street, all the even numbers are down the other side of the street. Okay, I think that's it. That's all you gotta know. I'm gonna stop recording here. So we'll